Today's video is Learning Target 3, Sketching Polynomial Graphs, and this is for our Unit 2B on nonlinear functions. We're going to discuss today how do you draw the graph of a polynomial. So what I have before you right now is a very general graph. Notice that when we're graphing polynomials, we end up with many curves to our graph. And there's a few important pieces that you need to know about. The first important piece is that you need to understand that this polynomial has been factored already for you. So each of these are called the factors. And that solving each of these and getting -2, -3, and +1, these are our roots. You can find those roots easily on our graph because they're the x-intercepts. Also, what's important for polynomial graphing is the direction that the graph is going, whether it is coming from below and then going up, or it could actually be reversed, where it could start from above and end going down. There's one last piece that you'll need to find as we're creating good sketches, and that is the y-intercept. And we're going to talk about how to find those. So understanding what are called the end behaviors, up and down, and which way the graph is curving. Understanding that the general shape is that it curves up through the first root, down through the second root, and then back up through the third root. And finding the correct y-intercept and making sure you understand the difference between factors and roots will get you a pretty good looking sketch of a graphed polynomial every time. So let's try this. In this graph, we're going to create the sketch of x minus 2 times x plus 3 times x minus 1. So remember, those are the factors. So the first thing I should do is use that to discover my roots. My roots are solved when these are set equal to 0. So the first root is 2, the second root is -3, and the third root is +1. Remember, these are also known as C. Next, I'm going to find a y-intercept. Remember, finding y-intercepts always happen when we plug a 0 in for x. That's how you get a y-intercept. So this would be y equals 0 is plugged into the x in the first factor, plugged into the x in the second factor, and plugged into the x in the third factor. I end up with -2 times 3 times -1, which is equal to a +6. So my y-intercept is at 0, 6. Also, since the value in front of the first factor is technically a +1, it's not negative, which means that we're going to have a graph that continues in the upwards direction. So our end behaviors, this is a down up graph, and it's because of a +1. So now let's start to sketch all those pieces. Our roots are plotted at a -3 and +2 and +1. This is going to get kind of skinny right in there. We have a y-intercept at 0, +6. And we have a graph that's going to start down here and end up here. So it'll be a graph that looks something like this. Now do know that this is not a perfect graph. It's not a perfect sketch, but it includes all the important pieces that you should understand about graphing any kind of polynomial function. again, let's try defining the same pieces, the roots, the y-intercept, and understanding the end behaviors of the second example. So first, let's find our roots. Our roots in this problem are going to be at -4, at -2, and at +1. So I'm going to go ahead and plot each of those. -4, -2, +1. Let's find a y-intercept by plugging in a 0 into all of our x's. -0 plus 4 times 0 plus 2 times 0 minus 1 gives me -4 times 2 times -1, which is a +8. So my y-intercept is at 0, 8. 0, 8, right there. And then lastly, our end behavior, the direction that the arrows are going at the beginning and end of the graph, remember, is controlled by looking at the value in front of the first factor. In this problem, it is a -1. So because of that -1, it means that this graph is going to continue in an overall downward direction, which means it starts by pointing up and ends by pointing down. So I'm going to draw a polynomial that starts coming from the upwards position, goes through the first factor, makes a turn, comes back up through the second factor, comes through the y-intercept, and then back down through the last root. So I have a upwards arrow in the beginning of my graph, and it continues to a downwards arrow. So that pretty much covers the type of graphing we're going to be doing in this class when we're graphing polynomials. There are three important pieces: the roots, the y-intercept, and understanding the end behavior. And you can always understand the end behavior by knowing, is my graph going to go eventually up, or is it going to go eventually down? Positives in front of our factors make the graph go up in the end, and a negative in front of the factor makes our graph go down in the end. If you have questions, send me a message through our text messaging service and I can answer you right away. Otherwise, you can write them down in your left column and share them when we get back in the class. Don't forget to click through and answer all the questions after the video.